Alright, so here's the review. So for this one, it just says to write the transformations, make the table, and state the domain and range. Notice there is no graph. Alright, so for the first one, let's talk about the transformations. So I always go for the easiest ones. This is a K value, which means it goes up or down. In this case, it does go down 3 units. This is left and right, so this goes right 1 unit. And this is my A value. It's greater than 1, so it's a vertical stretch by 5. Alright, now when we're looking at the table, we're going to see what affects X and what affects Y. So right 1 is the only thing that affects X. That's going to be X plus 1. And then for my Y values, the first thing we're going to do is multiply by 5, because that's the vertical stretch. So 5 times Y, and down 3 is minus 3. So 5Y minus 3. And if you've forgotten the parent function table, right here, it is -2, -1, 0, 1, and 2. Those are my X values. And for Y, you take the absolute value. The absolute value of -2 is positive 2, then positive 1, 0, positive 1, and 2. Those are my Y values. Alright, so for my X values, it looks like I'm going to add 1. So -2 plus 1 is -1. -1 plus 1 is 0. And then 0 plus 1 is 1, 2, and 3. So 1, 2, 3, 4, 5. Yeah, adding 1. For these other ones, a little bit different. We're going to multiply by 5. So 5 times 2 is 10. And then 10 minus 3 is 7. 5 times 1 is 5. 5 minus 3 is 2. 5 times 0 is 0. 0 minus 3 is -3. And then we have 5 times 1, which is 2. When you subtract 3, and then we're going to get another 7. Alright, for the domain, we know that's going to be all real numbers, so I'm going to do -infinity to infinity. And for the range, you can see that we did go down 3, so we know we either start or stop at -3, and since there's no reflection across the x-axis, down 3 just brings it from 0 to infinity down to -3 to infinity, and a bracket on that -3. Alright, for number 2, let's go and do the transformations on this. So the negative reflects it across the x-axis, and the +4 makes the graph go up 4 units. In terms of x, there's actually nothing affecting x here, but for y, we have the reflection across the x-axis, which makes the y's the opposite of what they were, and then up 4 means to add 4 to the y values afterwards. So x's stay -2, -1, 0, 1, 2. My y values, however, we take a negative times 2 is -2. -2 plus 4 is 2. 1, -1 plus 4 is 3. -0 is 0. 0 plus 4 is 4. -1 plus 4 is 3. And then a 2. Alright, again, domain does not change, so that's going to be all real numbers. This time we're facing down, so we're coming from -infinity. And our highest point we reach for the y values is up 4, so that's 4 with the bracket. Let's go and take a look at the next problems. So these ones say to solve the equations, and we have absolute value equations here. So let's go ahead and go through these. So the first thing you need to do is isolate the absolute value. So right here, we either add or subtract. If we have anything outside the absolute value, then we multiply or divide. So in this case, we're going to divide both sides by 6. And this leaves us with the absolute value of 4x is equal to 3. So now that our absolute value expression is isolated, we look at the constant, which is positive, and we solve 2 equations. 4x is equal to 3, and 4x is equal to -3, and it doesn't really matter which one you put first. So for the first one to solve for x, we just divide both sides by 4. So x is equal to 3/4. And the other one, we also divide by 4. And x is equal to -3/4. And again, you can test these in there. Like I said, I test them when I have variables on both sides. But yeah, so those are my 2 answers there. Let's go ahead and take a look at the next problem. Before I can say whether it is a no solution or I can actually solve it, I must first isolate the absolute value expression. So I'm going to subtract 3 first. So 2 times the absolute value of x minus 7 equals to -8. Divide both sides by 2. So the absolute value of x minus 7 is equal to -4. Since this is a negative number, the constant, that's going to be no solution. Alright, on to our next one. So before we solve this, we must isolate the absolute value expression. So we add 5 to both sides. 4 times the absolute value of x minus 2 is equal to 12. Then we're going to divide by 4. And we get the absolute value of x minus 2 is equal to 12 divided by 4 is going to be 3. Isolate it, constant is positive, so our two equations, x minus 2 equals positive 3 or x minus 2 equals negative 3. So here I'm going to add 2 to both sides. So we have x equals to 5 and x equals to negative 1. And again, you can plug those in and verify them, like 5 minus 2 is 3. The absolute value of 3 is 3. 3 times 4 is 12. 12 minus 5 is 7, so that's going to check out. Negative 1 minus 2 is negative 3, but the absolute value of negative 3 is 3. 3 times 4 is 12. 12 minus 5 is 7 again. Okay. So those are ways you can just check them. We have this next problem here. So here we have absolute values on both sides. We're going to treat this as our C, okay? So we're going to drop the absolute bars on both of them. So this is going to be my positive C, 4 plus x. I don't change anything. But my second one, I'm going to keep x minus 2 the same, drop the absolute bar. But this one, I'm going to do negative. So negative times 4 plus x. And then I'm going to work them out, right? So on this one, I'm going to do the steps once. I'm going to add 2 to this side. And I'm going to subtract x from this side. And what you see right here is x minus x goes away. Negative 2 plus 2 is 0. Equals 4 plus 2 is 6, and x minus x is gone. So 0 actually does not equal 6, so that answer part here is going to be extraneous because it really doesn't exist. For the next one, we're going to go and distribute that negative. So we have x minus 2 equals negative 4, and then negative x. Again, I'm going to move the x over at the same time. Then I move the constant over. So just remember, you have to get the variables to one side and the constants to the other side. So I always try to put my variables to the left and my constants to the right. So x plus x is 2x, negative 2 plus 2 is 0, negative 4 plus 2 is negative 2, and negative x plus x is 0. Here we divide both sides by 2, and x equals negative 1. Now I'm boxing my answer in, but I'm going to check whether it's extraneous or not. So we have negative 1 minus 2, which is negative 3. The absolute value of negative 3 is 3. And then we have 4 plus negative 1, which is 3. The absolute value of 3 is 3, so that answer does check out to be true. Alright, for the next one, same situation we have, or not same, but just a little similar. 3x minus 4 equals x, so I'm going to set this up. This is my c value. So first, 3x minus 4 equals positive c, so positive x, or 3x minus 4 equals negative c, which is going to be negative x in this case. Okay. So I'm going to go ahead and subtract 3x to the other side to isolate the variable. So 3x minus 3x is gone. We have negative 4 equals to negative 2x. Divide both sides by negative 2. And x equals positive 2. My other one, same process, subtract 3x from both sides. Negative 4 equals to negative 4x. Divide by negative 4. X equals 1. Now let's just verify this. 3 times 1 is 3. 3 minus 4 is negative 1, but the absolute value of negative 1 is 1. And that's 1, so that checks out. 2. 3 times 2 is 6. 6 minus 4 is 2. The absolute value of 2 is 2. Let me plug this in here. So 2 does equal 2. And there we go. Let's go ahead and take a look at number 8 next. Again, this is going to be my c value right here. So first we have 4x plus 5. Notice we're dropping the absolute bars. Equals positive c, so 2x plus 4. Our second one is going to be 4x plus 5 equals negative, and then 2x plus 4. Then we're just going to work this out. Once again, I move variables to the left. That's just my preference, and I move constants to the right. So 4x minus 2x is 2x, 5 minus 5 is 0, 2x minus 2x is 0, and 4 minus 5 is negative 1. Divide both sides by 2. X equals negative 1/2. For this one here, I'm going to distribute that negative first, so 4x plus 5 equals negative 2x minus 4. Okay, so once again, let's move the variables to the left side, and the constant, we're going to subtract that to the other side. So 4x plus 2x is 6x, 5 minus 5 is 0, negative 2x plus 2x is 0, and negative 4 minus 5 is negative 9. Divide both sides by 6, x equals negative 3 over 2. So again, you're going to plug these answers in to verify that they do work. 4 times negative 1/2, which would be negative 2. Negative 2 plus 3 is 3. The absolute value of 3 is 3. And then over here, 2 times negative 1/2 is negative 1. Negative 1 plus 4 is 3. So that checks out. Over here, we have 4 times negative 3 is negative 12. Negative 12 divided by 2 is negative 6. Negative 6 plus 5 is negative 1, but the absolute value of negative 1 is 1. And over here, negative 3 times 2 is negative 6. Negative 6 divided by 2 is negative 3. Negative 3 plus 4 is 1, and both answers check out to be true. All right, let's go ahead and take a look at these absolute inequalities here. And again, I use the split or between. So just like before, you still need to isolate the absolute value expression. So here we're going to start by subtracting 2 from both sides. So we get 5 times the absolute value of x is greater than or equal to 10. Then we're going to divide both sides by 5. And then we come up with the absolute value of x is greater than or equal to 10 divided by 2. 10 divided by 5 is 2. And here we can see this is going to be a split. So we have x is less than or equal to negative 2, or x is greater than or equal to positive 2. And that answer is solved because x is isolated on both of them. You don't have to algebraically move anything. And then we're going to make our graph. So closed circle at negative 2. And it's a split, so it goes to the left, the first one, and the second one is greater than or equal to 2, closed circle, positive 2, and it goes to the right. All right, for the next one, before we solve it, we do have to isolate the absolute value expression. So we're going to divide both sides by 2. And the absolute value of x minus 9 is less than negative 2. Now, at this point here, our c value is negative, and this is a less than, and we know that an absolute value will never be less than a negative number. So the answer here will be no solution. And once again, be careful if it is greater than a negative, the answer would be all real numbers. All right, let's go ahead and solve this last one here. All right, so first we have to isolate by dividing both sides by 4. So we get the absolute value of x minus 6 is less than or equal to 3. 12 divided by 4 is 3. This right here is going to be a between statement. So negative c first, less than or equal to x minus 6, less than or equal to positive c. So to isolate the x in the middle, we're just going to add 6 to the middle, the left, and the right. So negative 3 plus 6 is 3, less than or equal to x, because negative 6 plus 6 is just x remaining, and then 3 plus 6 is 9. And then for my graph, it's a between statement with closed circles because of the equal bars. We have from 3 to 9. All right, let's go on to the next page, or the back of this. All right, so we have more inequalities we need to solve. So again, before we solve this, we do have to isolate the absolute value expression. So first thing I'm going to do is add 7 to both sides. So 5 times the absolute value of x plus 8 is greater than 20. Divide both sides by 5. The absolute value of x plus 8 is greater than 20 divided by 5 is 4. Now that it's isolated and the constant is positive, it is a split statement. So x plus 8 is less than negative c, which is negative 4, or x plus 8 is greater than positive c, which is 4. And last, to isolate the x, we subtract 8 from both sides. So negative 4 minus 8 is negative 12. So I'm going to have to put this somewhere. Let's see. Let's put it right here. Or, and over here, again, we're going to subtract 8 from both sides. And 4 minus 8 is negative 2. So x is greater than negative 2. So there's my answer right there. In terms of the graph, they are splitting apart. The smaller one is negative 12. The bigger one in this case is negative 2. And there's my graph. All right, let's move on to the next one. First, we're going to start by subtracting 6 to isolate the absolute value expression. So you have the absolute value of negative 3x minus 2 is less than 2. All right, it is isolated. It is a positive c, so we're going to do a between statement because it's less than. So we get negative c is less than negative 3x minus 2, which is less than positive c, which is 2. All right, first thing we're going to do is to isolate, add the 2 to the left, the right, and the middle. So now we have 0 is less than negative 3x, which is less than 2 plus 2 is 4. Okay, and last we're going to divide every side by negative 3 to isolate the x. So we come up with the answer that 0 is less than x. Ooh, we just divided by a negative number, so that means we should flip the signs. So 0 is greater than x, which is greater than negative 4/3. And we're going to rewrite this from least to greatest, so negative 4/3 is less than x, which is less than 0. And in terms of the graph, let's see. Let's write that a little bit nicer. There you go. Negative 3/4. So we're going to have open circle to another open circle. This one would be negative 4/3, and this one is 0. All right, next problem. We draw a line here so we know where they're separated. All right, for this one, we're going to first subtract 10. All right, so the absolute value of 9 minus 2x, absolute value, is greater than or equal to negative 8. Okay. So this is the second case where we have a negative constant, but our inequality is greater than, right? So our absolute value expression, our function when graphed, is always greater than negative 8, so it's going to be all real numbers. All right, on to our next one. All right, so for these here, we're going to see which restriction they fall into. So negative 5 is greater than negative 7 and less than negative 1, so we plug it into this function. So 3x squared minus 2, so 3 times negative 5 squared minus 2. Negative 5 squared is 25. 25 times 3 is 75. 75 minus 2 is 73. All right, for the value of 2, 2 falls between negative 1 and 3. So 3 times x, so we change the x to 2, so 3 times 2 is 6. The 6 is greater than 3 but less than 10. So we plug it into the absolute value of 2 times x, which is 6 in this case, plus 1. 2 times 6 is 12. 12 plus 1 is 13. The absolute value of 13 is 13. And now we have negative 2, and we know that negative 2 falls between negative 7 and negative 1. So we do 3 times negative 2 squared minus 2. Negative 2 squared is 4. 4 times 3 is 12. 12 minus 2 is 10. All right, on to the graphing one here. So it says sketch the graph for the compound function, determine if the function is continuous or discontinuous, and determine and give the domain and range. All right, so for me, I'm going to make tables. So right here, this first one, I'm going to do it in blue. So x, y, x is less than 0, so I always start with the number they give, regardless of whether it's equal or not. So 0, negative 1, negative 2, right? Less than. And that's a less than sign, no equal to. I know this one's going to be open. Now to get my y values, notice it's just always 5, so we're going to change all these y values to 5. So 0, 5 is an open circle. Negative 1, 5 is a point, and then from here we just move on to the left. And there's that graph there. All right, for the next one, I'll do it in red. So it's going to be from 0 to 3. And we're we're going to plug these into 3 times x. So 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. They're both equal bars, so the first point and the second are going to be closed. Or sorry, the first and the last endpoints are going to be closed. Alright, so let's go ahead and plot these. So 0, 0 is a closed circle. We have 1, 3, 2, 6, and 3, 9 is another closed circle. Yeah. And there's that part. So just based off of this, they're not even connected, so that's discontinuous. Alright, for the last piece, do this one in green. So here we have xy. X is greater than 3, so 4, 5, 6, and this isn't open because it's not included. And we plug it into here, so 3 plus 2 is 5. This is a 4. 4 plus 2 is 6. 6 plus 2 is 8, and sorry, 5 plus 2 is 7. And 6 plus 2 is 8. And now we can graph this. So we have an open circle at 3, 5. 3, 1, 2, 3, 4, 5. And then closed circles all the way through. And there is your graph. So for the domain is from left to right. So we see this has an arrowhead going to negative infinity. And right here it's broken apart, but a closed circle, when I bring it down to here so I can see it's going to be closed. And it's connected until here. And at this point here, again, they're disconnected, but it does start, it ends there and it starts here, so it's a closed circle, and this goes towards infinity. Alright, so for the domain, we see that's going to be from negative infinity to positive infinity. And for the range, these may go on to positive infinity for x, but for y, they actually just remain that same number at 5. Alright, actually, you know what? I'm looking at this graph. I did graph this wrong, so let me fix that real quick. I mean, I have the right points, but when I graphed it, I did not graph that correctly, so let's take a look. So we had 3, 5, then we had 4, 6, 5, 7, and then 6, 8. Okay, there we go. So the domain didn't change. The domain's still negative infinity to positive infinity, but the range will change. The range is from bottom, this closed circle at 0, bracket, because it's close to the top. Now, this isn't the top, right? It looks like it's top, but we have an arrowhead right here, and that arrowhead goes towards infinity. So there's your domain and range. All right, let's take a look at the next one. Again, I'm just going to make a table. So this one is going to be negative 3. And it's from negative 10 to 0. So x, y. So negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. And the first one is closed. And the last one is open. Alright, so from here we just look at the y value. It's always negative 3 for all these. Alright, so at negative 10, negative 3, we have a closed circle. And for the y's, we go all the way to 0, and that's going to be an open circle. And then all these points in between, you just connect them. So there's our first piece. For the second one, I'll do red right here. So from 0 to 4, they're both going to be closed circles. All right. So right here in this one, 2 times 0 is 0. 0 minus 3 is negative 3. So 0, negative 3. 2 times 1 is 2. 2 minus 3 is negative 1. 2 times 2 is 4. 4 minus 3 is 1. 3 times 2 is 6. 6 minus 3 is 3. And then 8. 2 times 4 is 8. 8 minus 3 is 5. All right, so let's see this. So 0, -3, 1, -1, 2, 1, 3, 3, 1, 2, 3. All right, and that one is a closed circle as well. Did I get 4, 5? No, I did not. 1, 2, 3, 4, 5. There we go. Closed circle there. Connect our dots, and so far it is looking to seem continuous, but let's just verify with this last one here. So we have this last one. 4 is greater than 0, so 4, 5, 6, 7. And we have negative x plus 9 we're playing into. So 4, -4 plus 5 plus 9 is 5. -5 plus 9 is 4. -6 plus 9 is 3. And -7 plus 9 is 2. So at 4, 5, we have an open circle, but it's already filled in by that previous one. And we have 5, 4, 6, 3, 7, 2. And we're going to just make a graph, and there we go. All right. Now, in terms of is it continuous or discontinuous, well, all pieces are connected, so that's going to be continuous. The domain, this stops at -10, and it goes to positive infinity. For the range, bottom to top, so bottom is this actual arrowhead, right? This arrowhead actually goes down forever, that goes towards negative infinity. And it stops at this close point right here, which is 5. That has a bracket. All right, I'll let you try number 21 on your own. Let's go ahead and take a look at this last part right here, number 22. So it says write a piecewise function for f of x, use one absolute value. All right, so for me personally, we talked about ring notation. You can use set builder, you can use interval, that's your choice. But we know right here, so that's our first piece, that's a linear line. So I'll do the restriction. This is negative infinity to -5, so x is less than or equal to -5. Or you could say negative infinity to -5. That is your choice, how you want to do that. All right, these are just the domain restrictions. Now, this is a linear line, so I'm going right here. I'm going, let's see, here's a perfect point. So up to right 1. All right, so I know it's up to right 1, so my slope is 2 times x is going up to right 1. But if I kept following that pattern, then we can see the y-intercept is at 5, 6, 7. Because it's a linear line, you do have to try to find that y-intercept. So in this case, it's going to be positive 7. All right, for my next graph, we're going to do this constant line from this blue one to this one. That picture I have, restriction is going to be from -4 to 1. So in this case, -4 is less than or equal to x, which is less than or equal to, we'll call this one 1. All right, so that just allows me to see that right here I miscounted. So you got to be careful on that. So you can see how I stopped at -5, but it should have been -4. So just be careful on small things like that. Let me go and fix this just so you can have the correct answer here. So negative infinity to -4. All right. And really quickly, one thing I tend to do is if I make this one equal, this one's not equal, but if you left it like that, that's going to be absolutely fine. Okay. And if you're curious about the interval notation, it would be -4 and -1 with a bracket. Okay, and this is a constant line at y equals -1, so my equation is just -1. All right, and then for the last one here, if you look at the shape, it takes the shape of a V, which is absolute value, right? So if you've forgotten this equation, it's y equals a absolute value of x minus h plus k. So we can tell that it's supposed to be at the origin, but it's moved right 6, and it's moved down 6. It's still facing up, and the a value, the only a value I give right now is it's facing down negative, but it's not. So the absolute value of x right 6 is -6, and down 6 is also minus 6. So there's your equation right there. And your restriction is going to be from this value here, which is positive 1, less than or equal to x, less than or equal to, and this one I put equal to, but it shouldn't be because it's an open circle. So be careful on that, which is less than, and this value appears to be 9 for x. All right. And again, I'll complete this one for the answer key, but try that one on your own.